If you've seen this video, then skip to these times. So this is a re-upload of a video that I did, this one here, where I was recording a lot of stuff with my cell phone, and I didn't really think it was worthy, but now that video has 40,000 views, so I figure I should probably edit it and re-include it in the series as a numbered video. And I've edited out some stuff from the old video. If you want to watch it, there's a link in the description. And I've added some video that I was able to recover. Google Drive is stupid. Enjoy the show. Here's a little observation for you. I'm working on a route for the penstock. So I've been running a garden hose up the hill as far as I can, piecing together sections. And I figured I'd show you, because you guys haven't really seen this before. So you see right there, there's clearly no stream, and right here there's water, clearly a stream. So the water definitely goes underground. At least in this part of the hillside, I can't find any surface flowing water on this part of the hillside at all. If you care about it, the garden hose that I have is right down there, but I think a straight line would be more here than over there, so I need to reposition the garden hose over about 20 or 30 feet to this side of the hill, which gives me a better lineup with the spring, which is pretty much straight above me now. Let me zoom in. It's right up through there. Here's an additional observation. I was just standing on that stump right there, and in the middle of summer, down by my house, and all the ditches and everything are all dry, just bone dry. But up here, I know the spring continues to flow. And I imagine, I have to make this point, that this forest absorbs the entire output of the spring during the high summer. Or it just evaporates off the ground. I highly doubt that. I'm pretty sure it's from the trees. This is another part of the creek that I haven't, even I've never actually visited this part. Just because it's so, here's horizontal. It's just so steep. And it's hard to climb in here. Just to get good footing here is really rough. Like, this rock's moving, everything's sliding. I'm just sliding, trying to get up here. And I know some of you suggested rolling the pipe down or sliding it down, but I'm afraid that if I tried sliding it down this hill, that it would all just want to slide down, and I'd have no way of stopping it, and it'd all end up in a tangled coil at the bottom of the hill, or partway down. And I can't unroll it down the hill easily. There's a bunch of logs like that one there. Just logs everywhere that I'd have to remove. And I guess since I'm here, I'll do another flow measurement. I'm trying to compile a chart of flow versus time of the year to see approximately how many gallons of water I get per minute at different times of the year. Alright, so it started at 20 seconds into this clip. There's 40 seconds, 60 seconds, and basically a minute 15. So that's 198 watts of mechanical power, and we are collecting all of it. It's all going into the buckets since the last time I was up here. I still have to bring up a crowbar to work on getting that cleared out. I'm afraid that the rocks might be too big for me to move, but judging by the size of the other rocks in this area, I'm able to move these. Maybe not that one, but I think I should be able to move these out of the way, and have to be careful not to get like under an overhang and working under an overhang, so because that would be unsafe without any sort of shoring. And the filter bucket looks good. I'm not going to mess with that. The real reason I came up here is to take a garden hose and lay it down there, or maybe over there or something, to start to pick a line for the penstock. I figure since I'm going to be doing multiple trips up the hill soon here, then I could start dragging additional hoses up. So I have like those garden hoses that I was dragging up, and I have my other 2 hoses that I had for the little system down here. Well, actually just 1 hose, and then this additional one that I made a joke of in part 5, where I said I was using this. This is 3/4 inch, and I'm stretching it out to make it straight, because this had been coiled up for quite some time, and it was the inside part of the coil, so it was like the tightest coil too. So I'm stretching it out here. And one of my commenters said that it would kink. Well, first, yes, I do have this suspended the entire way. I just have it clamped there with a ratchet strap to my truck, and then the other end is just clamped to a tree. So one of my other commenters was saying that you have to be careful unrolling these because you could get a kink, and that's what I got. I had a kink right here. You can see the line there. But I put a clamp on it and then a heat gun to kind of straighten it out. And I think once this is all stretched out, and then I shouldn't be bending this at all anymore. I should be able to just pull it straight up the hill, and then this kink wouldn't actually like reform, because there wouldn't be any impetus for it to. And the other garden hose I have, so this garden hose is actually going to be pulled up the hill. So at the end, this end here will be attached to my 2 black pipes, which is going to be this one, and then I have another one there underneath my porch, which is the one that was here. So those 2 are going to be at the bottom, because presumably they can hold more pressure than the garden hose, and the garden hose is going to be near the top. And because I'm using the garden hose to kind of trace out where I think I'm going to put this, so I want to put the turbine house like a small basement with a lid. That's all it's going to be. Maybe 4 foot by 4 foot, 2 foot tall inside or so, and then a lid on top. And I'm going to make it all out of concrete except for the lid, obviously, and I'm going to try to seal it so it's soundproof, because our bedroom windows are right there, and we like to sleep with the windows open sometimes. A lot of the time, actually, most of the summer. And so the hose is going to run up along here. Just follow my finger, and I'm going to put a pipe through there so that my hose isn't running through there or over the ground. It's going to run underneath that drive culvert thing, and then up through the woods, kind of where that is, maybe on that side, but maybe over there, here further, and then straight up there, which is, as far as I can tell, a pretty straight shot. Actually, might be more of a straight shot going up there instead of up through there. Might have to go a little bit further over there. And today I've been working on connecting this green hose, which is, sorry, my hands are shaky, I need a drink, which is connected to the spring up there. And then, oh, geez, slippery. This hose, well, it's a whole collection of hoses. It's dripping water. This whole collection of hoses, including that 3/4 poly line, runs all the way down to the turbine site. So I'm pulling this up for the past hour in multiple different sections, and you know, it's kind of hard to manage 700 feet of stuff and get up the hill efficiently. And that's where it ends up, and that's the hose that I'm connecting it to. So that's extremely lucky. I'm going to connect these 2 and then sort the connection at the top, just for a temporary setup. Again, this is to work out the route of the water line that I'm going to put in. And there we go. At every point I could, I kept the screw connection for service if I need to. Not that I don't know. I hope I won't need to, but the option is there. And then I have a few of these type of splice joints, which is just a 1/2-inch barbed coupler. So a lot of this hose is like 1/2-inch hose. The actual inside diameter is probably closer to 5/8. So should be nice and restrictive. And here I have the hose connected. It's not a watertight connection because it's a tapered 3/4 pipe fitting to a garden hose, and that's not really how they're supposed to work. But it's okay. And then there was another little bit here, something had chewed through it, so I patched that. Okay, in theory, this hose here, which is down at my house now, is connected all the way to the top of the spring. I have not opened it, so I don't know what it's going to do. There were some kinks in the hose. There might be airlocks. There might be debris in the hose. I don't know. We'll see. All right. Well, we got a jet of water. It's pressurized. Hear bubbles coming out. I expect bubbles. This is an electrical gland fitting, and it's tightened down, I think, as far as it'll go. I don't know if it would be better to have that free flowing right now, or if the restriction is good, because my theory would be that the restriction would be, and it seems to be losing pressure, that the restriction would be keeping the pipe, any kinks there might be, keeping them open. I keep it from creating a vacuum, so it's reduced in pressure a lot here. Might be bubbles. I'm gonna shut this and let it maybe purge some bubbles. I have to do it extra slow because this is only, I think, 100 psi pipe, and I'm expecting 110 plus psi here. Okay, I've taken off the gland fitting there, and I've let it sit for a minute. Let's see what it does this time. It seems to have a lot of pressure. That's a lot of flow. Purging the air. I really don't know how long this will take to purge air, if it is in fact doing that right now, or if the pipe has been purged now. It's hard to say. There's a lot of places where this is kind of going downhill, so it could collect air in pockets pretty far up even. And this is a good example of friction in the pipe. You can see there's no pressure here because friction is consuming all of the pressure in the pipe. And I'm kind of surprised that it's still flowing. I kind of expected that this lower portion of water here would be creating a vacuum on the upper portions of garden hose and collapsing the garden hose. I didn't notice this before, but I was hearing some noise in the pipe. It seems to be coming from this area, and I see this. I don't know if this is new or old. This might be from when the pipe froze, or it might be a recent development. I don't know. We can hear air bubbles in there. Okay, I have replaced this. I just cut it off because it had the wrong fitting on here, and it's all glued and there's not enough to glue on. And I didn't have the other parts of this to make another end. But I saved enough here that I can reuse it some other time. So I glued on this fitting, which is 3/4 male, for this garden hose tip. Come on, focus. There we go. So I'm going to turn it on and we're going to see what it does. I think this is under full pressure now. I do need to hook up a pressure gauge to this to see what it does. I mean, how many PSI it's got. And I also have to clean the garbage out of here still, because this is where the turbine's going to go, in this area. All right, here we go. Do it slowly. I don't know what size jet that is, but I can assure you it is a very strong jet. Makes it rain. There's my ice collection tree. That would create a nice collection of ice, I think. Look at that mist. I suppose that would also act as some sort of cooling for the house. Swamp cooler. Okay, that bulge, the bulge that's up there that I showed you guys a little bit ago, it's still there. It's pushed out solid. So we're getting a lot of pressure, I know that for sure. I have replaced my little nozzle there, which is just a garden hose nozzle, with this union, because I needed something to adapt from male to male on this that I already have made up. And we're looking for close to 100 PSI. Actually 110 PSI. Come on, focus. And I'm going to turn the valve on here and we're going to see how high it goes. Okay, look at that. Looks like our math was correct. And we are getting full pressure here. Come on. So those go in. There's a little bit of parallax error there. So there we can see how much pressure we've got. Why would they make a gauge like that? It's 5 divisions, so 3 1/4 divided by 5. So I did some quick math there. That's 253 feet, but guess what? I'm holding it 2 feet above the ground. So down here, where they're stupid mud. Sorry about that. My boot was stuck. So there we are, 255 feet of head, which is, guess what? Exactly what we were working with. So all of my calculations were dead nuts on. Well, averaged together, they're dead nuts on, which is, I guess, how it should work. That's why we average things together. So I've been working with anywhere from 250 to 280 feet, but it turns out it's 255, just like we averaged. So I guess the whole point of this was to determine routing of where I'm going to drag the big line up, the big penstock, because this is only 3/4 and then 1/2 inch garden hose further up. So I do have a path generally laid out pretty good. Another thing I could have done is measure all of these pieces of hose before I put them up there, so I know exactly how long of a pipe I need. But calculations based on topographical data show that I need around 750 to 780 feet, and I have 800 feet of pipe. So that'll work. And I don't have a suitable turbine to run off of this with that jet or any jet. Oh, sorry guys, I was wrong. Okay, look at that. It's getting higher pressure. I think bubbles are coming out of the line at the top, which would mean more pressure. And anybody want to do the math? Yeah, I'll give you a second. Do 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 do. How many feet is that? 270 feet of head, not 255. It's closer to my maximum, 280. That's what I had assumed. So we have more working height than I had assumed. I have to redo my calculations. I will get more power. All of this is, of course, assuming that this is calibrated correctly. For reference, house pressure from a hose is anywhere from 40 to 80 psi. 80 is like the maximum, 40 is like a minimum usable number. So that's pretty cool. You can see it's clearly quite powerful. This is creating a mist as it interacts with that concrete block. I was just working on editing this on the back porch, and I hear it start doing this. I don't know what's causing it exactly. I don't know if there's actually air coming down the line that it's purging still, or what. This is like 20 minutes after I turned it on. Every one of those, because this is like 7 atmospheres, so every time there's a little bubble, it expands from, like, we'll say 1 cubic inch out to 7 cubic inches as it changes pressure here. So it's like a little explosion. I'm going to connect the pressure gauge here and see what it's doing, if it's actually gained pressure. Okay, we can see it's lower pressure now. So there are bubbles entering the line somewhere. And the reason that is, I bet I know exactly what's happening, or something like it. So this nozzle is too big, and it's letting too much water flow through at the bottom. So up high, way up there, it's actually at a vacuum somewhere on the hose, and it's sucking in air somewhere. Maybe one of the screw fittings from the garden hose is not tight enough, so it's sucking air. So I think if I put a smaller nozzle on here, it won't do that anymore. I guess the other thing that could have happened was I was actually out sucking the supply of water, which is possible. Anyways, I have a smaller diameter nozzle here. It actually doesn't look smaller diameter, but this is adjustable. If I screw this out, it pushes those little balls in and makes it smaller. So maybe not the most efficient jet geometry, but it's a good way of reducing the flow in a variable manner. Clearly it's not a compatible thread, but we can turn it into a full jet, which shoots pretty good, and then also crank it down to real fine jet too. So I'm going to leave it there for a while. There, you guys can see that. Let's see what this does. I can go over here. So we have tiny jet. So yeah, let's play with electronics and high voltage. So that's like maximum velocity jet, I'd say. Let's try that. Whoa! All right, here's what I've got. It kind of barely works. Back away because it's kind of loud. I tried that nozzle. I tried that nozzle full open, and of course it was getting too high volts, and my Victron solar charge controller there was tripping, and I think I went over volts on this and it's dead. But this, if I adjust it, it kind of makes 1 watt. There, 2 watts. So it is a functioning hydroelectric system. 3 watts, wow. But it's not anywhere near ideal. Let's see if we can get that higher. We're operating at a higher than rated voltage on that. There we are. So this has already surpassed my water wheel on output. And it's a little $10 turbine. Modified, of course. Of course, one thing that you always risk with those is, well, first that has a lifespan of maybe days, if you're lucky. And oftentimes the limiting factor here is voltage and current. So that's rated for very little current to begin with because that's tiny wires. And the tiny wires have tiny amounts of insulation. So if you go too high of a voltage, then it could burn out the insulation because it'll jump through the insulation. And well, right now it's running somewhere 38-40 volts, but open circuit that was showing 150 volts DC. And we can see here my watt meter is dead. You see the voltage there, 0 to 60, and I went over it like a lot. So I wonder if that'll reset, or maybe it's just toast. That's okay, it was only a few dollars. So I have that hooked up to the charge controller, which goes straight to the battery. The battery's been sitting since my wind turbine videos, so it needs a little bit of a charge. It's at 12.5 volts. So it is charging it. And I don't have the inverter hooked up at all. And one of my viewers said, what's it do with one of these? Let's see what it does at 117 psi. Actually, flowing pressure is less, probably like 80. I don't know, we'll see. And not only that, but I have this and this to try out. So we'll see what they do. Something to note on these. That guy was shooting extra hard, but it wasn't shooting any further than normal house pressure. Because once the water's dispersed, it gets a lot of air drag and slows down. I think this was just trying to flow too much water and the pressure went way down. And then this guy is like normal operation again. I think because these flow too much, the pressure decreases and then you're just working at house pressures. So it's nothing spectacular. Like, comment, subscribe. See you around.
Whoops.